Hello everyone, welcome to Learn Overflow. In this video, we will be discussing about bubble sort. We will see how this function works, what is bubble sort, and we will try to implement this in Python. We will also work on finding out the complexity of bubble sort. So what is bubble sort? Bubble sort, you can say, is the simplest sorting algorithm. So it works on repeated swapping, or we swap on repeatedly, the elements get swapped repeatedly and it works in that manner. So let's implement this on the array shown here. So this is the array, and here we will implement the bubble sort. These are the array elements, the 6, 2, 5, 8, 3 are the array elements, and here 0, 1, 2, 3, 4 are the array indexes of the given array. Clearly, the array length is n is 5. That is, if we take the array length to be n, the length becomes 5. So how this works? First, the we take two pointers. So there are two places we mark and as ij. So how it goes? We just say this is our the first position and this is our second position, right? So how it goes? We check if array at 0 in the first place is greater than array of 1. If we find any element is greater than the next element, then we swap it. So this happens if we're doing for the ascending order. In if you are sorting the elements in the descending order, so you can go with the reverse case. So I'm telling you for the ascending order sorting. So what it sees that if the element present at this position, that is the first position, is greater than like the when the sorting starts, it says if the element present in the first position is greater than the element in the second position, then we will swap the elements. All right, so this happens in this manner. We found this at uh, the 6 was greater than 2, so we swapped 2 and 6. Next, again our array our sorting algorithm would check for the second element and the third element. So when we check for the second and third element, we figure out the 6 is again greater than 5. So we go on, again we will swap these two elements. Now we swapped 2 and 6 first, then we swapped 6 and 5. Then we'll check for the element at the third position and the element at the fourth position. That is, we'll check for array index 2 and array index 3. So what we figure out? We figure out the 6 is less than 8. So if we find the element is less than 8, so where we go? We will not swap that element. We simply leave that element and not swap that element. We will move forward. Next, we'll check the array index 3, or the fourth position and the fifth position. So what we figure out when we check the fourth position and fifth position, we find out that array index, like the value at that particular index is 8, and the next value is 3. So we can see that 8 is greater than 3. So we'll swap that elements. After the first iteration, that the first running through the whole array, we find out that the largest element of the array, that is 8, is at the greatest position, that is at the last position, right? So we figure out that in the bubble sort, how it works, if you're sorting in the ascending order, then we figure out that in the first run, we see that the largest element in the array gets placed in the last position. So from the next element onwards, we don't need to check for this segment, right? Because we know that this segment is already sorted, right? We need to search, or we need to check for these elements, right? We need to check for these elements, that we need to sort this element, because the last position after the first run, the last position gets sorted. Let's see how the next positions work. So in the second run, in the second run, how it works, it again starts from the first position and checks with the second position element. So it finds out the 2 is less than 5. So if 2 is less than 5 and we are sorting it in the ascending order, then 2 is less than 5, there's no need of sort. Again it figures out that it moves on to the next element without any swap. So it figures out that 5 and 6 it gets. So it figures out 5 is less than 6. If 5 is less than 6, then there's no need of sorting again. Moving on, and check for the next two elements, that is 6 and 3, and then in 6 and 3 it finds, hey, we need to swap this. Why? Because 6 is greater than 3, right? So for that we need again to swap these elements. So after the second run, we find out that the element at the second last position gets sorted. So now we know that whatever it is, this position of our array is sorted. So we are confirmed that 6 and 8 are in their exact position of the sorted array. So we are left with this three positions and we need to sort them, right? So we need to check or sort this position and we need to find out the result. So that means this area still remains unsorted. In the third trial, how it goes, third trial it again sees for the first element and the second element. So it checks, it finds out that 2 and 5 are not in the it finds out that 2 and 5 are already in their original position. So what it does nothing, no swapping happens. Then it checks for the next two elements, that is the 5 and 3. So for 5 and 3, what it happens, it finds out that 5 is greater than 3, so there's a need of swap, so it swaps 5 and 3. It swaps 5 and 3, and after swapping 5 and 3, we find out that 5 is already in its uh, correct position. So after the third swap, the last three positions of the array gets correctly sorted. Right? We know that this position are in their original value. That after the sorted array is this area is already sorted. Right? So how it actually works? The maximum value gets placed at its position first. In case of ascending order sorting in bubble sort, but we are still not sure that this part is in sorted order or not. We need to check whether this part is in its sorted order or not. So in the fourth run, what happens? It again checks for this first two position and it finds out that these are already in sorted manner. So when it completes a particular run and it figures out that the array in that position is already in the sorted manner, then it comes out of the loop and says, hey, the array got sorted, right? This is the way it works. So how it got worked, I guess you can understand. So let's move on and understand the working in Python implementation. Let's understand the Python implementation of this. All right, let's see how this implementation works. So first we have def bubble sort, that is we are taking a function bubble sort and we are just passing the array within it. We're just giving the whole array within it. Now see how it works. We're just taking the length of this array as n. So that's the thing we did. That's the total length to be n and it returns 5 for this array. After that we take a we run a for loop and we run the for loop of I till the whole range, right? We run it for this whole 5 times, right? So starting from I equal to 0 till I equal to 4. Then within that outer for loop we run an inner for loop of j, and we do it in a manner that we run this for loop of j from I from 0 till n minus I minus 1. Okay, let's understand how this n minus I minus 1 works. Look, if I is 0, like in the first run the value of I is 0, right? So in the first run, how many till how long we check this value? We check this till the whole element, right? Till we just started from 0, 1, 2, 3, and 4. So we checked for the 5 elements in the first run. So in the first run, we check 5 elements and see if the value of I is 0, then what it happens? N minus 0 minus 1. So n is 5 and n minus 0 minus 1 is 4. So that gives the all the elements needs to be checked in the first run. When I is 0, then j goes from 0 till 4. Then see what happens within the loop. So within the loop we are checking if the value at that array of j is greater than value of array of j of I plus 1, then we will just swap this value. So this is the method of swapping in Python that we use. If you're using some other languages like Java or maybe C, C++, then you would require to use a swap function, or you need to swap using a temporary variable, or you can use you can just swap without using a temporary variables also. So this is the way we swap. Now let's see what this if statement does. So if is basically it checks that if array of j, so j is at 0 in the first run, say for the first run of this inner loop when I is 0. So in the first run it does like when j is at 0, and we check that if a array of j is greater than array of j plus 1. If j is 0, then j plus 1 is 1. So we check this two positions, right? That is the thing we are doing. We're just checking for the first two positions, and we find out that if array of j, like the smaller position array, like smaller array at the smaller position is value is greater and then the next position, then we swap that element. That's what we did in the whole thing. So this goes on, but till how long? Look, for the first run, this the j works till 4. But when I becomes 1 in the next run, when I becomes 1, then this j runs from 0 till n minus 1 minus 1. So n is 5, minus 1 is 4, minus again minus 1 is 3. So that's what became like this became our sorted array, and this remains our unsorted array. So in the next run, j runs only for these 4 elements. Since this becomes 0 till 3. So this is how this works. And for the range what it happens, the first position is inclusive and the last position is non-inclusive. That's why array of j plus 1 does not go out of bounds, right? So it just goes for 0, 1 and 2. J takes the values in the second run 0, 1 and 2, and therefore j plus 1 takes the value of 1, 2 and 3. And that manner this checking of if goes on and on and on. So after the second run, we found that this area or this value is sorted for us, right? After the second position, that's what it does. For the I being becoming 2 or the third run, so this value becomes n minus 2 minus 1. So 5 minus 2 is 3, minus 1 is 2. So 5 minus 2 is 3, minus 1 is 2. So how long does it work? J takes the value of 0 and 1 in the third run, and we find out that j plus 1 takes the value of 1 and 2. So so this works for this three elements, and swaps the element if a element at this position is greater than the value is greater than the next position. So this is the simple implementation of bubble sort, but you can improve its performance. Look, for this bubble sort, in case this happens in a step like if the array elements were 2, 3, 5, 8 and 6. So if it was like, so if the array elements were like 2, 3, 5, 8 and 6, then what would have happened? Just think of this condition. So first this would take the length, like n would take the length, so n becomes 5, right? So n becomes 5 for us, and then this works like I goes from a range of 0 till 5, and j goes from a range of 0 till 5, and ultimately if the if statement here doesn't work for these two elements, then it goes for this elements and this element. So this two doesn't work, then it works for this and this, even that the if isn't valid for that, since 5 is less than 8. And for the last one is 8 and 6. So this there becomes a swap, and what it happens after the first run, this swap happens that 8 and 6 get swapped after the first run. And what happens? Look, the array already becomes sorted, but our algorithm will work on will think that only 8 is sorted and the rest is still unsorted. So what happens? It will check for 2, 3 again, then 3, 5 again, then check for 5, 6 again, and consider the 6 is then sorted, right? That 6 is then sorted after the second run. then it again check for 2 3, and then check for 3 5, and consider the 5 is sorted after the third run. After the fourth run you check the 2 3 and can say that the whole array is sorted, right? This would work in our case. Look, we are just running our loop for a continuous long number of times, right? Suppose if the array length is not 5, if it was like 5,000 or 500,000, look how long it would work for just one swap. It would just go working again and again and again, and ultimately take a huge amount of time just to do nothing. It's just running through the loops and just trying to finish it anyhow. So we can improve it, right? Don't you think we should improve it, or we can improve it? There's definitely a way to improve a bubble sort. So what we can do, we'll try to find out what can be done. Look, in the first case we swapped 6 and 8, right? That was the only swap that happened within the first run when the array elements are like this. So in the second run, the our code like our function or our algorithm thinks that this long is sorted. So in the second run, if we are just going through 2 3 3 5 5 6 and ultimately figuring out that there isn't any swap happening, right? There isn't any swap happening. So what's that? So that array is sorted. That's what we can understand as humans. So let's our algorithm understand that part too. So in that, how we can change it, like we can check 2 3, we found 3 5, we found 6 8, and there isn't any swap within a particular uh, loop of I, right? We are checking for the whole array, and that's a loop of I. So we figured out there isn't any swap happening. So if there isn't any swap happening, then our array is sorted. We need to consider that, right? We can improve this function. Now we are trying to improve this function. So again we did the same thing. We took a def bubble sort, the function name we took as bubble sort, same as here. Then we took a length n, like we are storing the length of our array, and the same we did here. Then we are just taking a outer for loop of I and just running it till the range. That's the same thing we did here. And then look for this part here. So in this part, what we did, we look, this part is again the same, just this 3 lines. That's the same thing we did, but we added 2 3 more lines to make our function or the algorithm more useful. However we did it, we added here another line called, we took a variable called swapped and we named gave it a value false. So considering there isn't any swap happen in the loop, when the loop starts, we just considered that there isn't any swap in the loop in the first place. We just considered it in the first place. Now we are just going through this uh, uh, for statement. We are trying to swap the elements if there is a change happening, like if the value of a of j is greater than a of j plus 1, array of j is array of j plus 1 is greater, then we swap the element. In case when we just swap the element, we inputted another value called swap equal to true, right? We made our swap true. That is, we are marking the point that hey, our swap got done, we did some swap, right? Then within our outer for loop, within our outer for loop, we just try to figure out, like, if the swap is still false, like if this statement isn't executed, if this statement isn't executed, so that means there wasn't any swap happening. If this statement isn't executed, we just break out from our for loop, from a from the nested for loop, and we just say the swapping or the array is sorted, right? So we just simply inputted a single variable here saying our swap is false. So considering there isn't any swap in the first place, in case there a swap happens, we just say a swap happened, or making the swap variable true. Then we check if our swap is still false or a swap happened. In case our variable is still false, so that means in this case after 8 get placed in its correct position in the second place, look, there were 2 3 4 5 and 6, it checked for this element and there wasn't any chance of swap happening. So once swap didn't happen, we just say just break out of that loop. So it broke out of the loop, and how much times it actually run? So it just ran from a whole loop like n times, sorry, a one complete loop run, and the second one till this position. So it didn't run the whole position, like whole number of steps to just check how many value to just check whether the array is sorted or not. It just said on a quicker note that hey, that is sorted, right? Now let's discuss a bit about the complexity or the time complexity of bubble sort. How will you say that? So the time complexity of bubble sort is found out that it's n square. So if you are familiar with those methods of finding out the time complexity, then you should be calculating it uh, manually. But on a normal node or on an easy node, if there you can see two for statements running or two nested loops are running, then you can consider that to be a order of n square. That's the easy method or a assumption method of saying it's an order of n square. So when n square statement is achieved, n square order is achieved, or the worst case is achieved when the array is reverse sorted. So if you're trying to sort an array in ascending order and the array given to you is already in descending order, so what it does, every time it needs to swap, every time it needs to check, and the check becomes true. So every time if you need to do that, you will be requiring a much higher value, like higher time requirement is needed, right? So the worst case happens is an order of n square, and this happens when the array given to you is in the reverse or reverse sorted. Also, in the best case of bubble sort, but that's rare. In the best case of bubble sort, you can say it's order of n. Why is order of n and when it can occur? It's basically when you can see that the array is already sorted. If the array is already sorted and that array is given to you, so after the first run or after checking for this first this elements 2 3 5 6 and 8, it will say there's wasn't any swap and it will break out the loop, ultimately giving an just order of n. So it just check for this n elements, right? So that's the order of n. Similarly, if you just look for the boundary cases, so in the boundary cases you can say that bubble sort takes a minimum time when the elements are already sorted, right? So that's the best case, and boundary case can be that that much, that there's a minimum time it would need. In case you give it a sorted array, it would need the boundary cases, right? That's the requirement. All right. Thank you guys for watching this video. Hope this information is helpful for you. In case you have any query, just put them down in the comments below. I'll try to answer you in a much easier way possible. Thank you everyone. Hope to see you soon in our next video.